Hi everyone, this is Near sir. So today class we will study your 4th semester automobile mechanical. The subject is your theory of machine. In this subject there is a chapter, that is chapter number 3, that is your power transmissions. In the previous class we had already studied that the length of an open belt drive. So in today's class we will study the length of an cross belt drive. In the previous class we have studied that what is the difference between open belt drive and cross belt drive. We have known that there are 3 belt drives, that is open belt drive, cross belt drive and compound belt drive. In case of open belt drive, the direction of rotation of driver and the follower pulley are same. In case of cross belt drive, the direction of driver is opposite to the direction of the follower. And in case of compound belt drive, when the two pulleys, driver and follower, if there are several pulleys are intersected between the two pulleys, that is driver and follower, we can say compound belt drive is used. So today we will study the length of an cross belt drive. So we know that in case of cross belt drive, the direction of rotation of driver pulley and the driven pulley are opposite. That means if the driver pulley rotates in the clockwise direction, then the driven pulley rotates in the anti-clockwise direction. So let's see what are the figures of a cross belt drive. All of us know that the direction of driver rotation is opposite to the direction of rotation of follower. So this is the driver or bigger pulley or larger pulley, and where this is the smaller pulley, or we can say driven or follower pulley. Right? In case of open belt drive, from the driver pulley, the belt is like this. But in case of cross belt drive, we know that the belt leaves the larger pulley at this point and enters the smaller pulley at this point. Whereas in the upper case, the larger pulley, the belt leaves the smaller pulley at this point and enters the larger pulley at this point. So the first driver, or you can say larger pulley, the center is your O1, and in case of smaller pulley or driven pulley, the center is your O2. Here we will see the belt leaves the larger pulley at capital E and enters the smaller pulley at capital F. Similarly, the larger pulley, the belt enters here G and here H. And the left side point of the larger pulley is your J, and the right side point of the smaller pulley is your K. Right? Then at the point that is E, where the belt leaves the larger pulley, if we will draw the angle with the center, then it becomes alpha. Similarly, if we make this angle, this also same alpha. Similarly, in case of smaller pulley, if we make an angle with the point where the belt leaves the smaller pulley, this angle becomes alpha. Similarly, if we make an angle with the point where the belt leaves the smaller pulley, you can say this angle is also alpha. As you know that in case of open belt drive, we will draw a line which is parallel to EF. Similarly, here we will also make a line which is parallel to EF. Then this will be appear and this will be touched. If we extend the O1E towards the outside, then this will make the perpendicular at point M. Similarly, the radius of the larger pulley, you can say R1, and the radius of the smaller pulley, you can say R2, and the center distance between the larger pulley and smaller pulley is your small x. This one. Clear? This is the cross belt drive nominations. Now, let us know what are the unknown terms. Here unknown terms are let R1 and R2. What I am saying? R1 and R2. R1 is the radius of larger pulley and R2 is the radius of smaller pulley. So you can say R1 and R2 equal to radius, the ruler form is equal to radii. R&D double A. So radii of larger and smaller pulley respectively. That means R1 is the radius of larger pulley and small r2 is the radius of smaller pulley. Similarly, another unknown term is your small x. What is small x? Small x is the distance between two centers of the pulley. Small x is the distance between 2 pulleys. That is your X. Then we have to calculate the length of a cross belt drive. So the total length we can say capital L. So capital L is equal to total length of belt. So what is capital L? Capital is equal to total length of the belt. So here we will see the belt leaves the larger pulley. Here is the larger pulley. So the belt leaves the larger pulley at capital E and capital G. Similarly, in case of smaller pulley, the belt leaves at point capital H and at point capital F. We will see that when we study the different belt drives, we know that the downside of the belt is your tight side, as the larger pulley or the driver pulley pulls belt from the downside and delivers it to the upside. So the below side is your tight side and this one is your slack side. Similarly, make a parallel line with EF. Make a parallel line with EF, that is your O to M, and this will intersect the O1E extended portion at point M and make a perpendicular at M. So now from this figure, if we will calculate what is the length of the belt. So what is the length of the belt? You will see this G, J and E. G, J, E is the arc of the pulley. Next, E, F is the length of the belt. Next again, F, K, H. It is also the arc of the smaller pulley. Next, G, H. So this way we will calculate the total length of the cross belt. So if we will write in equation, we can write total length of belt. We will know that total length of the belt symbol is capital L. So capital L equal to, we can write arc G, J, E plus what is that? E, F plus what is that? Arc F, K, H plus G, H. So in this way, we can calculate the total length of the belt. So G, J, E, arc, next E, F, next F, K, H, arc, next G, H. The total, if we will add all of them, we will calculate the total length of the belt. So first we will see arc of G, J, E. Next arc of F, K, H. Here you will see G, J, E, arc. The midpoint is what? J. Then the arc G, J, E, we can write the twice of arc J, E. So as J is the midpoint of arc G, J, E, if we will write the twice of half of the arc J, E, then we can say the full arc. So in place of arc G, J, E, we can write twice of arc J, E. Understood? Plus E, F, same, plus in place of F, K, H, arc F, K, H, the midpoint is K. So we can write the total arc F, K, H equal to twice of arc F, K. If you will multiply 2 into the arc F, K, we will calculate the total length of the arc. So in case of arc F, K, H, we can write twice of arc F, K. Understood? Plus in case of G, H, right? You will see in the figure the length of E, F is equal to the length of G, H. So in place of G, H, we can also write E, F. So here in place of G, H, we write E, F. In the right hand side, curly bracket, you will write E, F equal to G, H. Complete. Then what we will see? Twice of arc J, E. Here twice of arc F, K. Here also one E, F. Here also one E, F. So what is that? Twice of E, F. So you can write twice of arc J, E plus twice of E, F plus twice of arc F, K. This becomes your equation 1. This becomes your equation 1. Or you may write also capital L equal to make common 2 from each term. As 2 is present in each term, we can take common 2. So 2 common, next square bracket, your arc JE plus EF plus arc Fk square bracket. You may take this as equation 1. So what is the equation 1? Total length of the cross belt drive capital L equal to twice of arc JE plus twice of EF plus twice of FK. This means this is the half, and if you will multiply 2, then it will complete the length of the belt. Make a note of this. Then we will calculate each term, that means arc JE value, EF value and arc FK value. After calculating these three value, we will put this in equation 1 so that we will get the length of the cross belt drive. So make a note. After that I will erase. Okay. So first we will calculate what is the value of arc JE. Next calculate what is the value of arc FK and what is the value of EF. So from the figure, see, from the figure, the value of arc JE equal how much? In the previous topic we have studied the length of an open belt drive. Here we will calculate the length of the arc equal to how much? The length of the arc is equal to radius into multiplication of angle. Radius into multiplication of angle. So here we will calculate the arc JE length. So what is the radius of this circle? R1. So radius into angle multiplied, then we will get arc JE length. So radius is R1 into multiplication of angle. What is this angle? We will see this is your 90 degree and this is your alpha. So 90 plus alpha. 90 means pi by 2 plus alpha. So understood? What is the length of arc JE? This is the arc JE. If you will calculate the length of the arc, then you will have to multiply two terms. That is, first one is your radius, second one is your angle. So radius is your R1 in case of larger pulley, and the angle made by JER is your 90 plus alpha. 90 plus alpha, that is pi by 2 plus alpha. Similarly, arc of JE, we will calculate arc of FK. Here you will see the arc FK is the radius of smaller pulley is R2 and the angle made by arc FK equal to similarly 90 plus alpha. So we can write similarly arc FK equal to FK means it is the case of smaller pulley. Then radius of smaller pulley, you know that R2 into angle is your pi by 2 plus alpha. So we will get now the two value. The remaining value is your EF. Now we calculate the value of EF. You will understand or not? The arc of J equal to radius of that pulley into angle made by this arc. Similarly, arc FK equal to radius of that pulley into angle made by arc. So next we will see there is a term is your alpha. So where we will get the alpha? Sorry, I have forgotten to make alpha angle. Your O2 M O1 makes an angle alpha. O2 M O1. This is a right angle triangle. It is 90 degree. So it is a right angle triangle. And in this right angle triangle, the angle M O2 O1 is your alpha. So you will see from triangle M O2 O1, the angle M O2 O1 equal to alpha, that is radian. So now we will calculate the value of alpha. Here we will see from triangle M O2 O1, sin alpha equal to, what is the value of sin alpha? Sin alpha means the front, this much. The front is your O1M divided by O1 O2. The sin alpha means O1M by O1 O2. From this figure you will see that the front side of alpha and the close with alpha. M O1 divided by O1 O2. So what is the value of O1M? O1M. See, O1M is equal to, we can write O1E plus EM. O1E plus em divided by, in place of O1 O2 we will write simply O1 and O2. So you will see what is the value of O1m. O1m means O1e plus em divided by O1 plus O2. Now what is O1e? O1e, what is that? This is the radius of the larger pulley. So larger pulley radius is how much? R1. So you can say in place of O1e we will write R1. Similarly, EM, see what is EM? EM is like O2F. What is O2F? O2F is the radius of smaller pulley, that is R2. So in place of O1e I will write R1, and in place of EM I will write R2. Next O1 O2. So we know that the distance from one pulley to another pulley O1 O2 is your x, small x. So the value of O1 O2 is your x. So sin alpha equal to R1 plus R2 by x. Now we will see the point where the belt leaves the pulley, that is E point. We know that this angle made by the vertical line with point E is very small. That means the alpha value is very small. If the one value is very small or one angle value is very small, then sine of that angle is very small. As you know that sine 0 is how much? 0. So we can write in place of sine alpha, we can write alpha. So we will write as the value of sine alpha is, as the value of alpha is very small. So in place of sine alpha, we can also write alpha. So we will write as the value of alpha is very small. As value of alpha is very small, we can write sin alpha equal to alpha. As you know that if sin alpha equal to alpha, then the value of sin alpha is equal to also alpha. So sin alpha equal to alpha equal to R1 plus R2 by x. So alpha equal to R1 plus R2 divided by x. We will remember this. We will apply in the next topic. So alpha equal to R1 plus R2 by x. Now we will calculate the length of EF. What is the length of EF? Here we will see what is EF, the value of EF. Now EF, we know that EF is parallel to O2M. From the figure you have seen EF is parallel to EM. So in place of EF we can write O2M. EF is parallel to O2M. So in place of EF we can write O2M. So equal to, from the triangle, you will see from the triangle O1, O2 and M, what is the value of O2M? From O2 to M, what is the value? O2M equal to root over under O1 O2 square minus O1M square. The value of O2M we can find out by making root over under O1 O2 square minus O1M square. Since from the right angle triangles O1 O2M, we can write O2M equal to root over under O1 O2 square minus O1M square. So you know that? Next, equal to, what is the value of O1 O2? Previously we have already known that from O1 and O2 the distance is small x. So here you can write small x square minus, what is the value of O1M? Recently we have calculated what is O1M. O1M is equal to O1E plus EM. O1E is the radius of larger pulley R1 plus EM is equal to the radius of smaller pulley R2. So in place of O1M we can write R1 plus R2 square right, equal to, next if we will multiply x square and divide x square in each term, then there will be no difference. So in between this square bracket x square make a multiplication and x square make a division. Then there will be no effect. So x square minus r1 plus r2 square. Next equal to, if this x square divided by x square, then what will happen? X square outside, then x square by x square is how much? 1 minus this x square will be divided here, that is r1 plus r2 by x whole square root over. Okay. Next, if you will put this x square to outside, then it will become x. And from the square bracket, if you will put any square value, then it becomes single value. So now it becomes x root over under 1 minus r1 plus r2 divided by x square. This is the value of EF. As it is very difficult value and we cannot put this value in this equation 1, so we have to make it simpler. So in order to make this simpler, we have to expand this equation by using binomial theorem. So next write, by using expanding this equation by using binomial theorem, we will get, see, this equation can be expanded by using binomial theorem. So after expanding, we will get EF equal to x square bracket 1 minus half r1 plus r2 divided by x square plus there are several values will be found. So after multiplying x with that, we will get, and neglecting the smaller value x, if you will multiply x with 1, then what will happen? X minus, if you will multiply x with this, then x square into x will be cancelled out. So the remaining part is r1 plus r2 square divided by x. 1x will be cancelled out from x square, 1x will be cancelled out with x, then the remaining part is your x, the 2 will multiply here, that is your 2x. So this is the simpler form after expanding this equation with binomial theorem. Now we will see, we are already getting the three values, that means the value of RJE and the value of EF and the value of RFK. Now substituting the value of RJE and EF and RFK in equation 1, we will get, what we will get, see, EF value equal to x minus r1 plus r2 square by 2x. In the previously we have calculated RJE value and RFK value. So here now I will write again equation 1. What is that? L equal to 2 square bracket RJE plus EF plus RFK. We have already calculated these three values. Now we put these three values in here. So what will happen? 2 into square bracket. What is the value of RJE? We know that this one is your R1 into pi by 2 plus alpha. Plus what is the value of EF? We have calculated recently. X minus R1 plus R2 square by 2x. Next, what is the value of FK? We have calculated already. That is your R2 into pi by 2 plus alpha. So here the 3 points, the value of 3 terms will be put here. In place of RJE, we will put here. In place of EF, we will put this. In place of RK, we will put this. Now make multiplication. R1 with pi by 2 and R1 with alpha. Similarly here, R2 into pi by 2, R2 into alpha. So in the next step, we will multiply here 2 square bracket, that is R1 into pi by 2 plus R2 into alpha plus x minus R1 plus R2 square by 2x plus R2 multiplication R2 into pi by 2 plus R2 into alpha. This is the total equation. Now in R1 into pi by 2, here R2 into pi by 2. So we will take common pi by 2 here. Similarly, here R1 into alpha, here R2 into alpha. We can take common from alpha. So next equation is your pi by 2 common, next remaining is your r1 plus r2. Similarly, alpha common, the remaining is your r1 plus r2. Similarly, the remaining terms are x minus r1 plus r2 square divided by 2x. Now, the 2 which is present outside the square bracket, we will multiply in each term. So, what will happen? That implies L equal to 2 into 2. 2 into pi by 2 means 2 cancelled out. The remaining term will be pi into r1 plus r2. Then if you will multiply 2 here, then what will comes? 2 into alpha into r1 plus r2. Similarly, x into 2 is your 2x minus. If you will multiply 2 into here, then 2 and 2 will be cancelled out. The remaining term will be r1 plus r2 the whole square divided by x. So this will become. After that, you will see there is a term alpha here. So now we will put the alpha value of alpha equal to how much? We know that the value of alpha equal to r1 plus r2 divided by x. Now put this value of alpha equal to r1 plus r2 by x in the above expression. So what will come? See, if you will put the value of alpha in the above equation or above expression, then what will come? See, L equal to pi into r1 plus r2 plus 2 into, in place of alpha you can write this, that is r1 plus r2 by x, this is the value of alpha, into the remaining r1 plus r2 plus the remaining 2x minus r1 plus r2 square divided by x. So this will come after putting the value of alpha equal to r1 plus r2 by x. Now we will simply make common, multiply and take common. That is, this will be same, that is pi into r1 plus r2 plus, what will happen? This r1 plus r2, this is also r1 plus r2. So what is r1 plus r2 square? So you can write 2 into r1 plus r2 square divided by x plus 2x minus the remaining terms r1 plus r2 square by x. Now you will see the r1 plus r2 square by x. Here is also r1 plus r2 square by x. So we will take common r1 plus r2 square by x. Now what will happen? That is pi into r1 plus r2 plus, take common r1 plus r2 square divided by x. So if you will make common from this, then the remaining terms will be 2, here nothing means 1 plus 2x. Now capital L equal to, we can write pi into r1 plus r2 plus 2 minus 1, how much? 1. So the remaining term is r1 plus r2 square by x plus 2x. This is our required equation, that is the length of a cross weld drive. Here we will see r1 r2 there, here we will see r1 r2 there. So this is the equation where we use the radius of the larger and smaller one. So in the right hand side you can write in terms of pulley radii. As this is the radius of larger pulley and this is the radius of smaller pulley. So this is, we can say that in terms of pulley radii. Now if in the question it will ask what is the length of a cross weld drive in terms of diameter, then we can write, we know that radius equal to how much? Diameter by 2. So in place of radius we can write diameter by 2. So for larger radius it is r1 and d1, for smaller radius it is r2 and d2. So now we can write the equation in terms of pulley diameter. So what will become? L equal to pi into d1 plus d2 divided by 2 plus d1 plus d2 square by 4x plus 2x. This is the required equation in terms of pulley diameter. So you can say in the right hand side in terms of pulley diameter. In terms of pulley diameter. So we will calculate. We have calculated the length of an enclosement drive L equal to pi r1 plus r2 plus r1 plus r2 square by x minus plus 2x. This is in terms of pulley radius or radii, and again L equal to pi d1 plus d2 by 2 plus d1 plus d2 square by 4x plus 2x. This is in terms of pulley diameter. So in the previous class we have calculated the length of an open belt drive. Today class we have calculated the length of a cross belt drive. This will be clear. In the next class we will go further in this belt drive chapter. After completion of belt drive we will discuss gear drive functions. Thank you for the class.